chapter number 5, number play. First of all, you must know what is consecutive numbers. So consecutive numbers are numbers that comes one after another in order with the difference of 1, okay, between them. Okay, that should come one after the another in order with the difference of 1. This is called as consecutive numbers, or we can just say continuous number. 1, 2, 3, 4, 5, 10, 11, 12, 13, 25, 26, 27. So these all are consecutive numbers. Consecutive numbers. So in the real life where you are using house numbers, okay, 101, 102, 103, 104. Okay. Next, consecutive even numbers. Even numbers 2, 4, 6, 8, 10, 12, 14. And consecutive odd numbers 1, 3, 5, 7, 11, 13, 15. Okay. Odd plus odd or odd minus odd. So you'll be getting the answer as even. Odd plus or minus odd. You'll be getting even. Even plus or minus even. So the answer will be even. Even plus even number is even. Even minus even number is even. Odd plus or minus even. So it's equal to odd. If both are odd, answer is even. Both are even, answer is even. If one is odd, one is even means answer is odd. So next, always, sometimes, or never. Okay, they may ask in 1 mark questions. Okay, whether it's always true, sometimes true, or never true. Okay, true or false question. First one, if A divides M and A divides N, then A divides M plus N and A divides M minus N also. Okay, I'm just taking A is equal to 3 and M is equal to 12. A divides M. A divides N also. Okay, so therefore, writes A divides M plus N. If you are adding 12 plus 15, 27. So 27 is divisible by A. That is 3. M minus N, minus 3. So minus 3 is divisible by 3. That is the meaning for this. Next, second one, if A divides A is divisible by K, then all multiples of A are divisible by K. For example, A is equal to 6, K is equal to 3. 6 is divisible by 3. Then multiples of 6, 6, 12, 18, 24, 30. Okay, multiples of 6 also is divisible by 3. That is the meaning. So next one is, if A is divisible by K, then A is divisible by all the factor of K. Example, A is equal to 24, K is equal to 6. 24 is divisible by 6. Now, the factor of 6, okay, the factor of 6, 1, 2, 3, 6. Now, all the factor of 6 also is divisible by, okay, so 24 is divisible by all the factor of 6. That's only the given. A is divisible by all the factor of K. Okay, so 24 is divisible by all the factor of 1, 2, 3, 6. The fourth one is, in general, if A is divisible by K and A is also divisible by M, then A is divisible by LCM of K and M. Okay, make a note of it. If a number is divisible by K as well as divisible by M, then the number is divisible by LCM of K and M. For example, so A is equal to 18. So K is 6 and M is 9. So 18 is divisible by both 6 and 9. In this case, right, 18 is divisible by the LCM of 6 and 9. So LCM of 6 and 9 is 18 is coming. Okay, so the number A is divisible by 18. Okay, so next one is remains. Okay, what remains? If the number, okay, find the number that has the remainder of 3 when divided by 5. Okay, remainder 3 when is divided by 5 means, right? So when the number is divisible by 5 is a multiples of a number 5k. So remainder is given as 3 means, so 5k plus 3. Question is given like that, a number is, okay, divisible by some other number, leaving the remainder means, leaving the remainder you just take it as extra 3. and divided by 5 means so 5 cube. So figure it out. 5.1 is given in page number 122. Okay, first question. The sum of 4 consecutive number is 34. What are these numbers? Okay, sum of 4 consecutive number is 34. Okay, so I can just choose. Okay, so I'm just going to choose the 4 consecutive numbers. So let x plus 1, okay, x plus 2 and x plus 3. Okay, so 1, 2, 3, 4 numbers. Okay, let x plus 1, x plus 2, x plus 3, or okay, let x plus 3 be the 4 consecutive numbers. Okay, be the 4 consecutive numbers. Okay, the sum of 4 consecutive number is given as 34. So sum means we have to add, if you are adding all the 4 numbers, so we have to get it as 34. Okay, sum means you can just take according to the question. I'm just going to add everything x. Okay, plus, right, so x plus 1. Okay, now plus x plus 2 plus x plus 3 is equal to 34. Right, so while adding, we can just ignore the brackets. So we'll just ignore the bracket and write, so x plus 1 plus x plus 2 plus x plus 3 is equal to 34. Add all the variable first. How many x? 1, 2, 3, 4x. Okay, x plus x plus x plus x is 4x. 4x plus, add the numbers. 1 plus 2 is 3, 3 plus 3 is 6. Right, so 4x plus 6 is equal to 34 is given. Now 4x is equal to 34. So plus 6, it will become minus 6. Now 4x is equal to, so we'll be getting 28. Now x is equal to 28 by 4. Okay, so 28 by 4 is 7. Now x is equal to 7 we are getting. Okay, x is equal to 7 means the first number is 7. Okay, so we can just easily finish it up. The balance 2 numbers. 7 means 7 plus 1, 7 plus 2, 7 plus 3. Okay, therefore we can just take 4 consecutive numbers are, okay, are. So first number is 7 means, so 7 plus 1 is 8, 9, 10. Okay, 7, 8, 9, 10 are our 4 consecutive numbers. So next one is, suppose P is the greatest of 5 consecutive numbers. Okay, among 5 consecutive numbers, P is the greatest. Describe the 4 numbers in terms of P. Okay, the highest number should be P. Okay, so P is the greatest of 5 consecutive numbers. Then everything should be less than P. So P minus 1, P minus 2, P minus 3, P minus 4. According to the condition, P should be the greatest. Okay, therefore the 5 consecutive numbers P, P minus 1, P minus 2, P minus 3, P minus 4. So next, right. So here only we are just using the 1 mark. Okay, always true, never true, sometimes true. Question number 3, for each statement below, determine whether it is always true, sometimes true, never true. Explain your answer. Okay, first one, the sum of 2 even number is a multiples of 3. Sum of 2 even number is a multiples of 3. So that is sometimes true. For example, 2 plus 4 is equal to 6. Yes, it's a multiples of 3. So 2 plus 8 is equal to 10. So it's not a multiples of 3. Therefore, sometimes true. Second one, if a number is not divisible by 18, then it's also not divisible by 9. This is also sometimes true. Why? Because 45 is divisible by 9, but it's not divisible by 18. 40 is neither divisible by 9 nor divisible by 18. So third one, if two numbers are not divisible by 6, then their sum is not divisible by 6. For example, 1 and 5. So 1 is not divisible by 6, 5 also not divisible by 6. But the sum, okay, the sum 5 plus 1 is 6, which is divisible by 6. Okay, sometimes it may be true. A fourth one, the sum of multiples of 6 and multiples of 9 is a multiples of 3. Okay, this is always true. Sum of multiples of 6. Okay, 6 multiples of 9. Okay, 9. If I adding these to 15, 15 divisible by 3. Okay, fine. Next, if I take 6 twos are 12. Okay, 9 twos are 18. Next one. Next pair. 12 plus 18. 30. 30 also is divisible by 3. So this will be always true. Okay, how we can identify means you have to take any two examples, okay, two numbers and substitute and check. Check the condition. Fifth one, the sum of a multiples of 6 and multiples of 3 is a multiples of 9. Sometimes true. For example, multiples of 6. Okay, 6 and 3, 9 is a multiples of 9. But 6 twos are 12. If I take 3, so 15. 15 is not multiples of 9. Right. So next. So question number 4. Find a few numbers that leaves a remainder of 2 when 1 is divided by 4. So write an algebraic expression to describe all such number. Okay. So if they are leaving the remainder, only one number is remaining in the remainder means we can write this is as, so plus 2 divided by 3 means, okay, if it's given only one condition, leaving the remainder 2 and divided by 3 means you will be writing as, okay, we can just write it as 3k plus 2 only for one condition. But here given the two conditions, okay, this is one condition and remainder 2 when divided by 4. Okay, for both remainder is same. Okay, both remainder is same. So therefore we can just take LCM of 3 and 4 into k plus 2. Okay, plus 2. Okay, now LCM of 3 and 4, 3 4s are 12. Okay, 12. The expression will be 12k plus 2. Okay, 12k plus 2. This is the expression. Now write the algebraic expression to describe all such numbers. Okay, first you can just take k is equal to 1. If you are taking k is equal to 1 means we are getting 14. K is equal to 2, 26. K is equal to 3, 38. This number, if you are taking any one numbers, this number, right? If you are dividing by 3, it will be leaving the remainder as 2. And, right, if you are dividing by 4, it will be leaving the remainder as 2. Okay. Now you check these numbers. For example, I am just taking 26. 26 I am taking. If 26 is divisible by divided by 3, is it leaving the remainder 2? We have to check. Is it leaving the remainder 2? How many times 3 in 26? Okay, 8 times, so remainder 2. And the same is 26. If you are dividing by 4, okay, that's also should leave the remainder as 2. How many times? 6 times. 24. So remainder 2. Okay, it's coming correct. Okay, this is like question number 5 is in puzzle. Okay, puzzle. I hold some bubbles, not too many. So when I group them in threes, okay, one stay with me. That means when I are just taking as 3, remainder is 1. So next, while trying to pair means double, okay, 2, 2. So try pairing them, it simply won't do. Okay, then means the distance is not coming as, okay, not giving the remainder as 0. A stubborn odd people remains in my view. That means, okay, odd numbers, remainder is coming as 1. So group them by 5. If you are grouping by 5 also, still, okay, 1 still around. So remainder is 1. But grouping by 7, the perfection is found. That means the remainder is coming as 0. When you are grouping by 7 alone, the remainder is coming as 0. So more than 100 would be for 2 bowl. Okay, that means 100, okay, would be for 2 bowl. Okay, can you tell me the number of bepels I hold? Actually, the pot is asking. Okay, how we can find out? Here we are having, okay, so we have to just divide it by 3, 2, 5. Okay, and leaving the remainder as 1. Leaving the remainder as 1. That is the case. See, LCM of 2, 3, and 5 into k plus the remainder is 1. See, LCM of 2, 3, 5 is 30 is coming. So the expression is 30k plus 1. Okay, now we have to just take, first you just take k is equal to 1, 30 into 1 plus 1, so 31. 30 into 2 plus 1, 61. 30 into 3, 90 plus 1 is 91. Okay, they are given, the answer is nearest to 100, not more than 100. So the number of apples is equal to 91. If you are taking 4, it will be going, okay, more than 100, more than 100. Okay, 91. And they have given, while dividing this 91 by 7, the remainder should be 0. We can just check it out. Okay, so 91 divided by 7. Okay, we can just take 1 sevens are 7, balance 2. It will become 21. So 3 sevens are 21. So remainder as 0. Okay, the perfection is found. Perfection is found. Therefore, the answer is 91. So question number 6. Okay, Tadagat has written several numbers that leaves a remainder of 2 when divided by 6. He claims if you add any 3 such numbers, the sum will always be a multiples of 6. Is Tadagat claims true? Okay. First, you can just write the expression. Okay, remainder is 2 divided by 6. So, only write 6k plus 2. Now, this is the expression. Now, we have to check whether this is sum will be always multiples of 6. Sum will always multiples of 6. First, you will find out few numbers. First, you just take k is equal to 1. Okay, 6k. That is 6 into 1 plus 1. 6 into 1 plus 2. Okay, 6 plus 2 is 8. Next number, if you are taking k is equal to 2, 14. K is equal to 3, 20. Okay, sum of the numbers 8 plus 14 plus 20, we are getting as 42. Adding 3 numbers, I am getting 42. Now 42 is the multiples of 6. Yes, so 6 sevens are 42. 42 is the multiples of 6. So the answer is yes. Answer is yes. So question number 7. When divided by 7, the number 661 leaves a remainder of 3. And 4779 leaves the remainder of 5. So without calculating, can you say that remainder the following expression will leave when divided by 7? Show the solution both algebraically and visually. Okay, I'm just taking only algebraically. Okay, first question 4779 plus 661. So now what is given? So when divided by 7, the number 661 leaves the remainder is 3. While dividing 4779, remainder is 5. For 4779, remainder is 5. 661, the remainder is 3 is given. Okay, so total remainder is coming as 8. Okay, 8 if you are dividing by 7, so the remainder is coming as 1. Okay, the remainder is coming as 1. Directly we can get. Okay, they ask us to divide by 7. So remainder 8. So 8 divided by 7 is, okay, remainder is 1. Now for the subtraction, okay, now 4779. So remainder is coming as 5. 661, the remainder is coming as 3. 5 minus 3 is 2. Okay, this is less than 7. Okay, the answer itself, remainder is 2. If it's more than 7, you just divide and find the remainder. As it's coming as less than 7, right? So the remainder answer is 2. Okay, this is a shortcut. We can just go with this. So 8th question. Find a number that leaves a remainder of 2 when divided by 3. A remainder of 3 when divided by 4. And remainder of 4 when divided by 5. So what is the smallest such number? Can you give a simple explanation of Why it is the smallest? So in this case, it's divisible by 3, 4, and 5. So we are just taking the LCM of 3, 4, 5. Minus 1. Okay, minus 1 I am just taking. Why minus 1? Right? So everywhere. Okay, here remainder is 2 divided by 3. So what is the difference? Okay, 3 minus 2. The difference is 3 minus 2 we are getting as 1 is the difference. Here remainder is 3 divided by 4. 4 minus 3 is 1. Remainder is 4 divided by 5. Okay, 5 minus 4 is 1. Okay, so that is the reason we are just minus 1. Now if you're finding the LCM of 3, 4, 5, so LCM is coming as 60. The smallest number is 60 minus 1 is 59. Okay, answer is 59. Now you can just cross verify it. Okay, whether if you are dividing, okay, 59 divided by 3. So we should leave the remainder as 2. How we can check? 1 3s are 3, balance 2, it will become 29. Okay, 9 3s are 27. So balance remainder 2 is coming. Okay, correct. The same as 59 divided by 4 you check, you will be getting the remainder as 3. 59 divided by 5 you check, you will be getting the remainder as 4. So therefore the answer is correct.